This thing turn off. All right, here we go. All right, so we are going to go over the odd problems first, and then we'll just do whatever we can for the rest of the class period. I do not have like a hardcore homework for tonight because I just want you to study however you feel is best. I have not put answers up to the review yet, but if you click on the entry for tomorrow for the actual test date on here, I will always put whatever study materials I think would be good for you to look at. The test review itself would be the best thing for you to look at. Like that's going to be the most beneficial one. I do not have answers yet. I said answers will be posted sometime today. They took away my morning planning period because I had professional development, and then during seventh period, I've got to go check my daughter out from Barry. So I'll get it done hopefully sometime today. It has to be today, right? Because test is tomorrow. So I'll try to get those answers up. But I also put links to several other things, and these are things that we have done in class. So the limits involving infinity, we did that one. And I said answers are on pages right here next to it. Says, well, I'll just zoom in so you can read it. Where am I? Here I am. All right. Answers are on pages 37 to 40 of the August 25th class notes. So if you want to see the answers to those, what did I say, 45 to something? So we have to scroll all the way down to those pages. That's way down here. Here we go. So here's where I started working those problems out. Down here somewhere. Is that it? What did I say? Oh, 37 to 40. Okay, so let me go back up here. So here we go. So there are the answers to that. So the answers to everything else are in here. So there's limits review, all types, and the answers, limit derivatives, answers to, they're all on that same notes. You may have to browse around a little bit, but it tells you where the answers are. The one thing I do want to point out, and I meant to put this on the review, but I forgot to do it the day that I made copies of it. There will be some problems like these at the bottom of this sheet. If you remember doing this sheet, the limit derivatives sheet, I will give you some problems like that where if you remember, all you're doing is writing down this is f of x, this is the point of tangency, and you're done. You don't have to actually solve it. You don't have to do anything with it. It's just a pick apart the components of that limit, and we'll make sure to do a couple of those today since I forgot to put it on the hiccups. Since I forgot to put it on the official review. So, all that said, those things are there, and the answers to that are here as well. It says, what did it say? On pages 2 through 8 of the August 30th notes. Now that's actually during second period, but that was the where I could find most of them worked out for you. And there are the answers to the bottom 8 there, and that's all you have to do. Just f of x equals blah, a equals blah, and you're done. Okay, so on to the actual review. You are supposed to do the odd problems. Which ones would you like to look at? 47. Yeah, there were. I would say most of you did not really do well on those last ones. So maybe we need to spend some time on section G. Is that a good idea? So 47. Okay, so we are finding the derivative. All right. So for this one, I did tell you what the shortcut technique is. And once we finish this test, we will lock into the shortcuts for the rest of the year. There is a certain value in knowing the limit approach and all this. Y'all probably don't think it's that valuable, but for this test, I do want you to arrive at these answers through limits, and I will look at your work and make sure that your work makes sense. There's always a few people who think that they just write enough stuff, I'm not going to notice that it doesn't make any sense, and they magically have the right answer in the end. So I will look at your work to make sure that you're doing it correctly. But since we do know the shortcut, let's go ahead and knock out the answer really quick. What will the answer end up being? 4x minus 7. And we're just going to put that on hold. So we at least know what we should end up with. And for derivatives, if you're not finding the slope at a specific point, if it's not the slope at x equals 3 or something like that, I like to do the derivative limit, the limit as h approaches 0 of f of x plus h minus f of x all over h. And I create the limit using that formula. Then once I create the limit, I have to go through and solve it through the limiting techniques. So these are definitely the most labor-intensive problems. I think I'm going to come over here and work f of x plus h on the side. So that would be 2 times the quantity x plus h squared, 7 times the quantity x plus h, and then plus a 1. And I want to completely expand that out. How quickly can you do that? Okay, so x plus h squared, you have to square that first. That's x squared plus 2xh plus h squared. I have no exponents on x plus h here, so I can go ahead and distribute the negative 7. And now I will distribute the 2. And if you are confident in your expansion, you want to skip that middle step, have at it. Kind of dangerous. Very easy to just brain fart and do something careless with all of this work. I'm going to take all of that. All of that is going to go in the place of the f of x plus h right here. And honestly, I think that's the hardest part of this problem. If you can get that expanded correctly, I think everything else by comparison is easier than what we just did. But there is still a lot to do. So I'm going to plug that in. 2x squared plus 4xh plus 2h squared minus 7x minus 7h plus 1. All of that is my f of x plus h. Then minus my f of x, and f of x needs to go in parentheses. That's my original equation. 2x squared minus 7x plus 1. All that's over h, and we are doing the limit as h is approaching 0. Yeah. What should happen in the numerator? You said that exactly as wrong as you possibly could, which means you're actually kind of close. It's not all the h's cancel, it's everything except everything that doesn't have an h cancels. All right, so you were almost there. You just happen to say it perfectly backwards. So everything that does not have an h should cancel. And if you're not confident in your ability to skip steps without screwing up, I wouldn't try to cancel it yet. I would actually write out the step where you distribute that negative. So I'm not going to touch anything up here. I think your biggest risk of error by including this step is you just accidentally copy something down incorrectly, which is really easy for me to do because I'm talking while I do this, and that's not safe. I think I did that correctly. But if I did not do it correctly, then I might run into a situation right here. Everything that does not have an h should go away, should subtract out. So I'm starting here with a 2x squared. There's no h there. Here's a negative 2x squared. They cancel. There's a negative 7x, no h. Here's a positive 7x, they cancel. Here's a positive 1, no h. Here's a negative 1, they subtract out. You're good? Then I am left with 4xh plus 2h squared minus 7h all over an h, and we are now very close to being finished. Bless you! What do I do? What do I do here? Not yet. Factor the h out of the numerator. That'll leave you a 4x. They'll leave you with a 2h and a minus 7. Right? By the way, it's not wrong. Like if you want to try plugging in right here, you can. But you're gonna get 0 over 0, which just means you're not done yet. We have to make sure something cancels. Now I can divide out these h's. H divided by h is 1. Those go away. And now that I've canceled, I can plug in 0. Just remember, we're plugging in 0 for h, not for x. So we're left with 4x plus 2 times 4x plus 2 times 0 minus 7, which is exactly what we said we should get a long time ago. How are we? Questions out there? That's probably the worst problem on the entire review, I think. Is there a worse one? $40 what? 5? Okay, 45 is a good one. Y'all calm down. 45. 45. Oh, seriously. Kids. Children. All right. Find the equation of a line. What do we need? Well, that's true. We need a point and a slope. Right. The point you get by plugging your x coordinate into the equation. That'll be the square root of 16 minus 7. 16 minus 7 is 9. Square root of 9 is 3. So we have an ordered pair of 16, 3. Now the slope, that's where we set up the limit. And if I have the point, this is not a general derivative like the last one we did. If I have the point, I like to use the limit as x approaches the point for my approach. So it's the limit as x approaches 16 of f of x minus f of 16 over fx minus 16. And kind of like the last problem, we've got to create the limit first. Then once we create it, we kind of reset and we have to solve it. This one's not as hard to set up as the h one. F of x is root x minus 7. F of 16 is 3. We had to figure that out to get the point. And then the denominator we will leave alone. Are we okay with the setup? Good. All right, now we kind of regroup, and it's like we have a new problem. How do I solve this limit? We're going to use conjugates on this one. If you tried plugging in, you're going to get 0 divided by 0. So my conjugate is the square root of x minus 7 plus 3 on top and bottom. Good. We do not expand. We don't change the numerator. We only multiply out. I'm sorry, I said that completely wrong. We do not expand the denominator. We only multiply out the two that are the actual conjugates. And so that would become the limit as x goes to 16. Just copying that down. My denominator, we're not going to change. X minus 16 times root x minus 7 plus 3. The numerator, however, will become root x minus 7 times root x minus 7. That is x minus 7. Negative 3 times positive 3 is negative 9. And what are we seeing? Yep, that is an x minus 16. That will cancel with this x minus 16. If everything in the numerator goes away, there is a 1 left over, and I would encourage you to write the 1 just so you don't accidentally forget it in your answer. Once I cancel top and bottom, I can take that 16, plug it in for my remaining x, and you'll end up with an answer for the limit of 1 over 6. We okay? Any questions out there? All right. Now, don't be so happy that you did something good that you quit. That's not the answer. The question asks for the equation of a line. So I've got to write the equation of a line, and it said normal, which means perpendicular to the tangent. So if this is the tangent slope, that means, therefore, the normal slope is what? And I heard it a second ago. It's negative 6. Whoops, not negative 1. Negative. Why can't I write? Negative 6. Holy cow. Okay. We good? One tiny, tiny, easy step remaining. Take that point, take that slope, write your answer in point slope form, and then run away to the next problem. We do not have to write it in slope intercept form. This is our final answer. We good? These were the problems everybody was skipping, and they are the most labor-intensive, worst problems of the test. Anything else? Do we have any other questions on the odds? No? 43? So negative 1/2? 43, negative 1/2, is that right? Okay, I did that really quick in my head. Let me see. 3x squared. Oh, you're right. It is negative 1/8. You're right. Negative 1/8 is the answer to 43. And again, I'm going to talk 43 really quickly. This is what I did. I will look, I'm going to keep stressing this. I will look at your work to make sure that your limit approach is how you're getting your answer. But what I did in my head is the slope of the tangent would be f prime. That's 3x squared plus 5, right? So I just did the derivative shortcut. My slope at negative 1 would be 3 times negative 1 squared plus 5. That's 8. That's your tangent slope. Therefore, my normal slope is negative 1/8. So that's what I was trying to do very quickly in my head, and I just made a sign error. I did negative 3 plus 5 instead of 3 plus 5. But if you know that shortcut and you have time to do this, you can check your answer very quickly. You can check your answer very quickly. Not get your answer, but you can check your answer quickly with that method. I taught you that trick for a reason, just so you can check your answers. Yeah? Anything else? By the way, the limit approach, you'll end up having to use synthetic division on 43 to finish it. If you do limits on 43, you'll have to use synthetic division to complete the problem. Anything else? 37. Negative 2 from the left would be negative 1. Mm-hmm. Yep. Yep. Yeah, and that's a good question because on 37, a lot of people will look at this and say we are approaching negative 2 from the left. You'll identify the correct piece to look at, but then people will plug in something like negative 2.1. They won't plug in the actual number. They plug in something just to the left. There's only one time when you test a number just barely to the left. Do you remember what that is? It's when you have that infinity situation. If you have a number divided by 0, there is no divided by 0 here. So we don't need to do that here. Anything else? Was there a question? I don't know. 31? 9? 39? Negative 2? That's going to be negative 1. You have to look at left and right separately. Actually, yeah, I didn't notice that. But yeah, on 38, you should have also gotten negative 1. And since 37 and 38 have the same answer, then that's your answer for 39. We good? Going to work on the evens? Okay, so see what you can do on the evens. I'm going to pause everything over here and start working this out so I can have the answers to upload later. All right, talking about numbers 16 and 17. All right, so I have heard several times, the question, how do you know if you are supposed to look at it from the left and the right or something like that? And there's not a cut and dry answer to that one. As far as whether or not you need to pay attention to the from above and from below part, the answer to that, bless you, is if you have two functions interacting with each other, really, I'll say this, to know whether or not you need to look at left and right, I'm going to go back to that first question. If you do have two functions interacting with each other in any way, it's safest to look at left and right separately, right? So because here I see a G and an F, it's better to think about left and right separately. Here I see an F plus a G, it's better to think about left and right separately. Now, as I say that, for this one right here, I'm going to isolate the inside. We're going to find the limit of that interior piece, which I've always called U, and I'm going to do the limit as x approaches -2 of that, f of x. And for this one, I'm not going to look at left and right separately this time, because if I look at f, as f is approaching -2, both left and right are going to the same place. Now, if there were a jump, if I were trying to analyze what's happening as x approaches 3 for f, now because those give different answers, I need to look at left and right separately. But because left and right are going to the same place for f here, those are both approaching a y value of 3. And since I'm going to use that answer, that's not my final answer, that's just a small piece of this, I now am noticing that I'm coming towards 3 from below. So it's going to be 3 from the left. Now I reset my limit. I go back to my original limit, which is g of f of x. And I'm replacing that f of x with a u. And that, you don't really have to do this. It's just, I'm just appeasing the gods of math. And I just found out that that u, that f of x, was approaching 3 from the left. And so now I go to g. As I approach 3 from the left, I'm coming up here at 2. And because that's the final answer, I don't care that it's 2 from below. I'm not going to use this anymore. I'm done. Yeah? Yeah. Now for 18, I would like to be able to just look at 3 from both sides simultaneously, just like I did on number 16. But if you look at f, as we approach 3, the left and the right sides are giving us different answers. And so that means I need to look at left and right completely independently. So we're going to do the limit as x approaches 3 from the left of f of x plus g of x. Because at the moment it looks like it does not exist plus does not exist, which would not exist. But when you look at them separately, you end up getting something different. F of x, as we approach 3 from the left, this is f over here, right? Isn't f on the left? F on the left, it rhymes, like elf on a shelf. What? Anyway, we're approaching 0 plus, and g, as we approach 3 from the left, is 2. So my left side is approaching 2. Now, I'm going to see what happens as we approach 3 from the right of f plus g. And the right side of 3, f is going up towards 3. The right side of g is coming down at -1, and 3 plus -1 is 2. Both of those are the same. Therefore, this answer is 2. Are we good? Bad? Don't want to move on and keep doing your own thing? We have about, what, 15 minutes? Okay. Do we have any other questions? Like, y'all were raising your hands just as I started in the back. Are we okay, or do you need me to come clear things up? Everybody's cool? All right. Anybody else? Why do y'all keep asking me these questions? Oh, gosh. 6x over 2x would be 3x. Is it 9? Let me do that again. Oh, it's 6x squared. Hold on. 6x squared over 2x. Oh, it is 3x. I'm getting 9 again. Did anybody else get 9 on number 24? You did? Yeah. All right, let's jump. Let's see what 24 has to show for us. Okay, so 24. We could try plugging in, but you're going to have a really hard time because when you plug in, you do get 0 divided by 0, which means something should cancel. And for this one, we're going to factor, and this is probably the factoring you're least comfortable with. The denominator is easy, x plus 3, x minus 3. I hope that's easy. The numerator will factor out a 2. That gives you x cubed minus 27. And x cubed minus 27 is a difference of cubes. That's x cubed minus 3 cubed, which we can go blah, blah, blah. Good? Do you remember that? Blah, blah, blah? It's a, so I have my a value is x, my b value is 3. So it's a, which is x, b, which is 3. Then it's a squared, a times b, and then b squared. So it's a, b, a squared, a, b, b squared. And then the signs follow the SOAP. That's the mnemonic device that actually makes sense. It's just fun to say. But the first sign is the same. So if I started with subtraction, minus, second sign is opposite, and the third sign is always positive. And that's how we will factor the x cubed minus 27. And if you can do that, the rest of it's not bad. We'll cancel the x minus 3s. We'll plug in over x plus 3, x minus 3. X minus 3 divided by x minus 3 is 1. Those divide out. And we're left with, plug in 3. 2 times 3 squared is 9. 3 times 3 is 9. 9 is 9 over 3 plus 3 is 6. 2 times 27, 54, divided by 6 is 9. Are we good? Anything else? Anything else? All right, I'll freeze things up. I'm going to keep sitting over here and working. Is that okay? Does anybody have any other questions out there? Yes, ma'am. You can fill up your water bottle. Can you leave your phone here, please? Did you leave your phone? Leave your phone. This goes along with the same stuff that's at the very end of the review. But you're identifying, am I doing the limit as x approaches a of f of x minus f of a over x minus a? Are we using that method, or are we using the limit as h approaches 0 of f of a plus h minus f of a over h? So first identify those two things, and once you do that, the rest of it, especially if it's the first one, falls into place very nicely. Because if it is x approaches a number, like x approaches 16 instead of h approaches 0, then the a value is what x is approaching. So a is 16, and the function is the part that comes before the constant in the numerator. So the function would just be the square root of x, and that's all you have to do. That is it. So those are the easy ones. Those are the easy ones. 9 is a little bit more difficult because it is the h method. And for that one, the a value is the number that's being added to the h. So when I see 3 plus h, that tells me that a is 3. The function itself is a little bit more difficult because unlike the first one, it's not explicitly part of the formula. But for the function, we look at the structure of that first piece. And the structure of the function is stuff squared. So my function is x squared. So and that's all you do. Those are very, very, very quick problems once you figure them out. And you're probably hoping maybe that I put like 30 of these on the test. And even 30 would only take you like 5 minutes. Right. So anyway, so those are those problems, and we did talk about those once upon a time. And there will be some problems like that on the test. I just forgot to put it on the review. So just know that will be something you'll have to do. We have about 4 minutes. So while I have your attention, is there anything else on the review you want me to look at? Where's my cursor? There he is. Any other limits that All right, what are we thinking? Number 10. The function is x cubed minus x squared, and you're at 3. Yeah. Your answer to 10 is literally f of x is x cubed minus x squared, and your a value is 3. That's all. Cosine x at pi. Anything else? We're ready as we're going to be? All right. Use your time tonight to study however you feel is best for you. What? Yeah, it's literally going to be like, here's what I'm doing. It's going to look, well, the first problems I've had don't have any, but yeah, it'll have my work with it. So it's not only answers, it's going to have my work too.